Hey everybody, so Thomas asked a question about page 185, so that's 4.4, so that's on my worksheets. I believe that was, let me just double check that for a second, that was 4D, so 4D as in Donald, 4D, graphing quadratics, vertex form. So he had a question about these two, values that x may take, values that y may take. Those are the words that I introduced in my lesson. Values x may take is otherwise known as the domain. Values y may take is otherwise known as the range. So what are those two questions asking for? They're just asking for this. So if I looked at the first example, if I wanted to draw a quick sketch of A, okay? Draw a quick sketch of A. I know that this graph, my vertex, because this is technically plus 0, right? My vertex here is 4, 0, which means that is my vertex, okay? Now, is this going to be facing up or down? Well, it's up because it's positive, which means it's going to look something like that, okay? That's all I know. Obviously, this is not a great graph, and this is supposed to be my axis of symmetry. I'm no artist. Values x may take. Well, we know that this graph will go on forever, which means, are there any x values that are not possible? So values x may take in this question, all of them. Okay, so there's not a single x value that's not possible. And you can tell by both the graph and by the equation. So for example, if I subbed in x if I put negative 5 for x, or 10 for x, or 15 for x, or 1,000,000 for x, I will be able to solve this. Okay, so there's no x value that's not possible in this case. And visually, looking at the graph, you can see this graph will go on forever. This parabola will go on forever, which means every single x value will have a corresponding y value. Now, how about the y values? What y values may this question 1a take? Well, the y values that they may take are all y values except y needs to be bigger than or equal to 0. Because if I look at this graph, can my y equal to negative 3? Nope, because my parabola is clearly above the x-axis. Okay, let's take a look at another example. So I'm just going to choose a different color. So let's say, I don't know, I chose C. So I know my vertex is at 3, 2. So if I wanted to draw a quick graph, negative 3, negative 2. Okay, so that's my vertex. Is this opening up or down? That's positive, so it's clearly opening up. Now, notice how I'm not even writing the correct points, nor am I even trying to find out where these x-intercepts are, because I don't care. I'm just looking at the behavior of my parabola. So I know that my vertex is at negative 3, 2, and I know, since this is positive, that it's opening up. So I can answer these last two questions. X values may take all of them. Now, in fact, all parabolas, the x values that any parabola can take, the x values that any parabola can take are always going to be every single x value. Because if you think about it, what x value is not possible for me to just plug in here? I can replace it. So then you must be wondering, well, why ask this question then? That's kind of dumb. If the x values are possible for every single parabola, why ask this? Well, that's because when you move into later grades, you're going to get graphs where not all x values are possible. And for those that are curious, as an example, you might have a graph that looks like, I don't know, something like this, where you can see there's a gap in the middle, so these x values maybe between negative 2 and 2 are not possible. Okay, but of course this is grade 11, 12 business, okay, or more grade 12. Okay, now what y values are possible in this case? Well, clearly, it's every y value needs to be bigger than negative 2. So y needs to be bigger than negative 2. Done. Okay? Alright, hopefully that answers your question. Yeah, take care.